Small parts for 3D printing, sometimes you can see that you've got scarring. Sometimes you're going to need support material, and the generated support material that you get from Bamboo Slicer is just too big, or it leaves too many marks, or you end up taking it off and breaking it apart. You could have very thin parts as well. Here's text. You can see that we've got like these little tiny gaps there. You can also have just very thin little parts. During the printing, there's enough force for them to break. So you have all these issues printing detailed parts, whether that be text, figurines, or just even like thin-walled pieces. Today, I'm going to show you 8 practical solutions. So 8 things that you can actually just do to fix that, and 1 test print torture test. Number 1 is generating custom supports using resin support. So we're going to use a slicing software that is specifically for resin printing. Instead of using the auto-generated supports that you can see here, we're going to be using supports that come from this resin software. So if you haven't seen, this one is called Chi2 Box. You basically import your model, add custom supports, and then you export your model. This is how easy it is. You grab your STL, drag it into Chi2, right? You go to the support tab, and then you go auto support. Now, this is going to give you, it's going to like raise it up. It's going to show you all the overhang. And then you've got all these different settings to play with. If I hit apply, you can see that I've got like this nice density of support points along this part. I could make this bigger or smaller depending on the part, right? So this is going to be something that you're going to have to play with. It really just depends on your model. But you can see how easy it was to generate these supports. And then all you're going to do is select your model and go export model. And that is going to download it. And then you can bring it into your slicing software like this. How cool is that? So I would actually print this with no support enabled in the slicing software because I've already generated the support here. And I'll show you in a little bit because this is printing the support and the model at really high resolution and really high quality. We're going to make changes to the settings. So the support you can actually print with different settings. So I'll show you that in a little bit. Number 2 is the wall generator. So the wall generator is by default, it's set to classic. And what this does is it's a fixed width extrusion. So the plastic coming out of the nozzle is always the same width. But what Arachne does, so if you change this wall generator, you only have 2 options, classic or Arachne, and it'll be a variable width extrusion. I like to think of it like a tap where you can rotate the handle to get a different amount of water out. It'll adjust how much flow of plastic you actually get to create different details. So you can do a little bit less for smaller bits. You can do a little bit more if it wants to fill in gaps. I've got classic on the left and Arachne on the right. I've just sliced it, and you can see here on the left, if I change this to line type, you can see I've got this weird white bit in the middle, right? And that's called gap infill. And if I change this to line width, you can see that I've got a gap infill. It's a very thin layer. And then I've got this very consistent extrusion width on the wall. Sometimes that's a good thing. Sometimes you want a clean extrusion width, but mainly with these detailed parts, pretty much always Arachne is going to outperform it. Because when I go over to here and I look at Arachne, you can see that my width has actually changed. It's increased. So if I look at the color scale here, it's gone a bit thicker on this outer wall. So I've got no infill here, none of that weird gap infill that we had with the classic mode, which means that when it prints, it's just going to print one pass around this whole letter, for example. That is going to be a lot cleaner. Next, continuing on with our text example, there's a few settings here that I guarantee you won't know. So firstly, there's a developer mode in Bamboo Studio. We're going to actually have to enable that for this next bit. And we're going to use a setting called interface shells. Here, I've just sliced it like it normally is, like my default settings. And if I go down to that top surface, you can see it's like assuming that the text is there. It hasn't actually printed the text yet. The text is the next layer up like this, right? Then it prints the text. Like you can see here, I've got like these thicker bits that it puts in the middle, but then a bit lower, it's got like the infill. And all of that change is going to create rough spots. It's going to create surface defects. And that's just a problem. So let's go through the steps now. So we go File, Preferences, and then I scroll down to Develop Mode. So you've got to turn that on. I've already got mine on. And then I'm going to go to my global settings, click on this part, type in interface shells, and then I'm going to turn that on. So what it says here for interface shells, when there's different volumes, then it's going to treat them separately. But you can't just leave it at that. You also have to change this other setting, only one wall on top surfaces. You can't have this enabled. You have to say not applied. And then once you do that, you can hit slice, and we'll see now, if I go down to this top layer, it's just printing one solid piece. It's completely ignoring the fact that there's text there. And then the text goes on top. That is the cleanest way that you can print text. You'll get the best top surface. But if I go up more, you can see here under line type, I've got these purple regions, and that is internal solid infill. I can turn it on and off here. So you can see that like highlighting. And that is going to be an issue because those are really thick pieces. And then you got a thin piece here, and that's just going to create some issues there. So you basically go detect narrow internal solid infill and you turn that off. And then if I hit slice, instead of before how it was, where it was going thicker and thinner, now it's just a monotonic line. That is a way cleaner way to print this part. Change those settings if you want better text. Number 4 is speed. So changing the speed is basically something we do to lower vibrations, and we have more accurate placement of the actual plastic that we're laying down. And this also gives us more time to cool the actual plastic. You should have slightly more accurate parts. Go to your speeds and change them. Usually you're going to be printing much smaller layer heights with very fine or detailed parts. So you want to change this anyway, but from your standard profile, you're probably looking at halving the speed. And the main speed parameter that we would change, if you could only pick one, would be the outer wall speed. If you compare this to a normal 0.2 millimeter profile, so you can see here that I've changed it. If I put this onto the defaults, you can see I have 200 as the outer wall speed. The inner wall is 350, right? And then the infill is 450. So these are like much different to these numbers here. We want to be lowering that speed quite a lot. Number 5 is seam position. So the actual seam of your part, you can change this to be towards the back. And you can see here on this image on the right that I've got the seam that's going down towards the back. But you can also paint these on these like natural edges of the part here. Cool thing, if you go to line type, you can hide the supports just by clicking these buttons here. Let's just look at them from the front. And if I have seams selected, it's the white dots. At the first one here, the default, they're kind of just randomly allocated like to where it was like easily going to be made by the slicer. And then for the one where I've selected in the back is the middle one here. You can see that it's basically right in the middle most of the time. And then here, I've actually painted it on. So if I go back to prepare and click this part, you can click this little seam painting tool and paint it along these natural edges. So I wanted the seam to be along like the hairline here, and you can change your brush size and do all that. And then like say there was another edge, somewhere here, I could like just go and like select it. And that would make it so the seam will try to snap to that position. So you use the natural edge of any of your parts to hide it. Number 6 is avoid crossing walls. This is a really easy one to do. You just basically enable avoid crossing walls, and you're going to go from something like this. I've shown the travel moves here. Those are the blue lines, to something like this. So you literally just turn on this setting, and what the travel moves will start to do is move in the internal sections of your part. If it's like not too complicated, if it doesn't have to take a massive detour, it'll do that. And you can see that I'm just going to have less crossing at the boundaries of my part, and that'll make the surface quality a little bit better. And then number 7 is resolution nozzle diameter. So resolution's a really big one. Obviously smaller will be better. You capture more detail. But if you're using supports, the custom supports, the support material doesn't have to be printed with the same layer height. When I print a part, I can click on the part and then go to quality and change the layer height. And if I go to the objects tab, I can also change the layer height there. So you can have 2 different objects, which is what I've got here. I've got the model in one object, and then the support, I've just separated it into another object, okay? So now when I go to quality under my objects tab, I can actually change. You can see here, I've changed the layer height of the support material to 0.16. So double the layer height of the figurine, which I click here, which is still set to 0.8, which is the default for my profile here. So if I do that, then it'll print the support material at a different layer height than the actual part. I can do that for any setting or most settings. I can change the speed. So I can make the support material quicker. It can print way faster. Stuff it. I just go, 200, 250 for the outer wall and the inner wall. With the support material, I don't really care how much quality I get there. I could even change the strength and change the wall loops down. So the support material doesn't need to be strong. You could be printed with one wall loop. So the support now is being printed with all these different settings. So when I say resolution, it's not just about saying, hey, I'm going to use 0.08. It's saying, hey, I'm going to use 0.08 where it matters, which is obviously just the part, right? And then the support material, you can like have that different. And that'll save you heaps of time. Like this could save you like 40, 50% print time, which is a huge difference, especially if you're doing this for a business or you're doing it for a hobby and you just want more out of your machine. Okay. And the next thing on resolution is nozzle diameter. So this is a 0.4 millimeter nozzle, the outlet, let's say, and this is a 0.2. It's half the diameter, but it actually means that it's 4 times bigger. 0.4 is 4 times bigger. This means there is a massive change between the 0.2 and the 0.4. It's bigger than you would think, but what most people don't do is redo their filament optimization. And that brings us to filament optimization. 0.2 millimeter nozzle acts way differently to a 0.4. Just because of how much smaller it is, the cooling rates are totally different. So what you need to do is do a temperature tower. You can look these up on MakerWorld really easily. You can do a flow rate optimization. So in Bamboo Slicer, you can do this under the calibration tab. This will help you get the exact right amount of material coming out of your nozzle. Then it's looking at flow dynamics. Again, this one can be done in Bamboo Slicer. And basically, this is kind of the equivalent of when you squeeze toothpaste, right? You apply a force to the toothpaste and a little bit of toothpaste comes out. When you stop applying the force, a little bit of toothpaste still flows out because you've created the pressure, right? When you apply a little bit of force to the filament, it will create some flow. And when you stop applying it, there'll be still a tiny bit more flow left. Flow dynamics will take that into account. And then retraction. So when you have starting and stopping, which is especially important for printing detailed parts like those miniatures and using like custom support material, we have lots of stopping and starting. You want to dial in your retraction settings. So you can look up retraction tests again on MakerWorld. I'll also put a link under this post for the one that we use. This is an advanced one that goes through heaps of different settings in one print. It takes like a bit more setup time. You do this one print and then you'll just like have like perfect retraction settings for that setup. So the whole point of this is you get the right amount of material extruded at the right time that cools in the right place. That is why we do those calibrations. And what you can do just to save yourself a little bit of time, or if you just want to get most of the results without all the effort, is just buy material that has these settings already given to you. So Filaform is our brand of material, and we have optimized this and provide the settings to you just to download and import into Bamboo Studio or Prusa Slicer. All right, so now putting it to the test, putting this into practice, here is a torture test that you can print that'll help you assess lots of different features of your part. Now, this obviously looks a bit different to a miniature or the text, but if you look closely, it's got a lot of different features that you'll have to print with those parts. So it's got these bridges here, it's got overhands, it's got text here and here. You've got lots of little retractions here and here, and then you've got tiny little gaps here and here where all the cylinders are. So these will actually they're meant to like pop in and pop out. And if I go here, all I have to do is right click, add primitive, and you just click KSR FDM test. If you wanted to really push it, you could lower the size, yeah? So obviously the gaps then would be different. So 0.2, if I make this half the size, that gap will now be 0.1, right? Push the limits if you want to get like smaller and smaller. If you can print this really well with your printer, with your material, with your new settings that you've changed, you create a profile from these settings, then you're going to be in a really good spot to print anything that is small and detailed. To learn more, you can jump to our 3D printing community. We have free courses in the classroom section. We've got a calendar section where we do weekly Q&As. You can also post to the community when you have an issue or when you want to even just share a win. The link is in the description and our bio, and go and print the future. If you have any questions, let me know.